Hello everyone, we're back again with another Leetcode problem. This is an easy problem, but this is a part of blind 75 list. So this problem, although easy, it will actually help you build concepts around some of the data structures. And also this is one of those problems which can be approached in different ways. So you can start with a naive way and then try to make it more efficient. Okay. So let's go to the problem description. We are given two strings, S and T, and we have to return true if S and T are anagrams. So here is the definition of an anagram. Anagram is if two words or phrases or strings are made of, say, same letters, say rat, and although this is not a word, so these two strings are anagrams because they are actually made up of same letters with same frequency. That's also important. Or say cat and act, these are also anagrams because you see they are actually made up of same letters with same frequency. Okay, so if two of my input strings are anagrams, I have to return true. For example, here you can see two inputs, and if you see, like, they have like A has, in the first one, A comes 3 times, and then G is frequency is 1, R's frequency is 1, M is 1. Okay, and what was the other thing? N is also comes once. Similarly, here you can see we have 3 A's, right? And then we have 1 M, 1 G, and 1 N, and 1 R, right? Okay, so that means they are made up, these two strings or words are actually made up of same letters with same frequency. That's why they're anagrams. In the second example, you see rat and car, although there is 1 R in both, 1 A in both, but this last one doesn't match. Like, the second word has C and the first word has T, so they're not anagrams. So look at the constraints. Both of the inputs consists of lowercase English letters. Okay, so how can we solve this? I would suggest everyone to pause the video and think for a while, and then we can come back, okay? So if you're back, obviously, the first one of the thoughts that may come naturally is, how do what sorry, what if I sort these characters, right? So if I sort these characters, it will look like A, then G, R, M, N, right? So this will look like this. This one will also look like A, G, R, M, N, right? So after sorting, if both of these are the same, then we can say they're anagrams, right? In the second example, let's look at this one. After sorting, rat looks like ART, and car looks like ACR, right? So these two after sorting doesn't look the same. And then we can say this is not an anagram. So if I do this sorting stuff, then what is the time complexity of the algorithm? So the time complexity of the algorithm is going to be the sorting the first. Okay, so here is one thing. If these S and T, their lengths are not the same, then we can immediately say that they're not anagram, right? The reason is for them to be anagram, like for the number of characters must be the same. If the number of characters are not the same, then we don't even need to check anything else, right? Because there is no way that the frequency of the characters are going to be the same. So in that case, we can say that we only can go forward, like do sorting and other stuff, if the length of the strings are the same. So if the length of string S is, say, n, and length of string T is also n, right? In that case, if both of the lengths are n, then the sorting for the first one, like S, will take order of n log n. We know sorting algorithm, right? And also the sorting, the second one will take n log n. So the sorting part will take n log n. Next is I have to check if these sorted characters are the same. And that check will checking n characters against n characters, like one comparison for each. For n characters, this checking will take order of n, right? So in total is order of n log n plus order of n, which is order of n log n, right? Because this is the dominant term. So this will take order of n log n. And basically, we can sort it in place. That means not in place, actually. After sorting it, we have to actually sort it, put the sorted thing in a in an external memory, right? In an array or something. So that will be order of n memory for n characters, right? So the space is going to be this. Okay, so this is one way to solve it. So let's see if we can improve it. So from order of n log n, obviously an improvement is order of n, if we can do it in order of n. Okay, so let's see if we can think about that. So if you remember, like initially when we were thinking like taking a frequency, right? And checking the frequency of the characters, if the frequency of the characters match. So how about for each character, if I just update the frequency somewhere, and whenever we are talking about frequency, the first thing that should come in mind is a hash table or hash map. As I said, like hash tables and hash maps are very important tools or data structures to solve problems. They help in most designing in most efficient algorithms. So if we declare a hash map, and for S, say we create the hash map, and eventually the hash map will look like this. The key is the character, and this is the value. The frequency is the value. So this is the character and the value. How many of these characters are there? Then R is 1, M is 1, N is 1, right? Okay. For S, for T, sorry, we'll get the same thing. Maybe R1, M1, G1, right? N1. So what we can do is we can build two hash maps, and then after we build them, we can just start reading from there. So building these hash maps, how much time it will take? So for each characters, I will just do one operation on the hash map. That is updating the hash map or inserting into the hash map. Each operation is order of 1. For n characters to put them in the hash map, it will take order of n, right? Okay, order of n to build the hash map. Similarly, this is order of n here, because the character length is, string length has to be the same, right? So order of n to build the hash map. So this is just building part. Now next, what I have to do is I have to check, right? I have to check the frequency. So what I do is I start reading from the hash map, I read one character at a time, and then I will, for A, and then I will check, okay, do you have A? I will ask here, do you have A? If you have A, then what's the frequency? Okay, so asking this thing will take order of 1, because in hash map we can extract the value in order of 1 time. So how many times you are going to do this? So for n, maximum of n characters, right? Maximum of n characters. It might be less than n because some characters might be duplicate, but let's take for maximum. Each character is suppose distinct. So for n characters, we'll do this checking like n times, right? N times. So this is also, checking is also order of n. So in total, building and checking, if you add them together, it's order of n, right? So this is an awesome thing, order of n thing. And the other thing is how much space we need. Well, it looks like we need order of n space, right? Thing is, although it looks like we have order of n space, which is in, but if you think carefully, you see that the characters that we have is only lowercase English characters. That means at most, the highest value for n is going to be 26, right? So at most 26 space is going to be taken, which is constant, right? So whatever my string might be very large, like with thousands of characters, but the space that I will be taking in the hash map is going to be constant. I am not going to take more than 26 space. So space, so this is the time. So time is order of n, and the space is going to be order of 1 constant. That's because of this constraint. Okay, so let's try to code this. Now we have an order of n algorithm. If I go and try to solve this, not this one. Okay, so if I try to solve this, let's see. Obviously, at the beginning, I have to check if the lengths are the same, right? If the lengths are not the same, then I don't need to do anything. Return false. Else what I do is I declare a hash map. Okay, so let's try to make it a little bit more efficient. Let's think about this. Oh, okay, sorry. Okay, so we actually had built 2 hash maps, right? You remember, like A was 3 times, then N was 1, M was 1, and G was 1, and R was 1, right? And in the second hash map, we also again had like N1, M1, A3, G, and R once, right? So we had 2 hash maps. So instead of that, can we do this? Like for string S, we just keep on adding the elements. Then we can use the same hash map. So when you are actually reading string T, we can just keep on reducing. So whenever we get an A, we just decrease it by 1. We get an N in, so say here, we get an A, we decrease it to 2. We get an N, we decrease this value to 0. Then we get an M, we decrease this value to M. So probably you have got my idea. The thing is, if it's an anagram, what's going to happen is if the frequency of the characters in S and T are going to be the same. So when I am checking S, I am just increasing. When I am checking T, I am just decreasing on the same hash map. In that case, what's going to happen is if the number of characters are the same, after increasing and decreasing the same number of times, all the values are going to be 0, right? So next I can check if all the values are 0, right? If all the values are 0. So only it's a slightly more space efficient because I don't need to maintain like 2 hash maps. Instead, just I can work on 1 hash map, right? So let's try to solve in that way. Say hash map of this is character and integer map equals to new hash map. So here is where we are going to update our frequency. So this is comma. Okay, so what's they're showing? Oh, okay, so I didn't put new. I don't know what's the issue here. Oh, okay, there's some weird issue. Anyways, next what I can do is I can run a for loop to read each of the characters. So how do I break down this string S into the characters? I can just use toCharacter function. Now this will return an array of characters, right? And it will give me, I'm running a for loop. So basically I'm reading each characters from this character array. And what I do is map dot put yeah, I had actually made a mistake of spelling. Okay. Okay, so toCharacter array. There's the toCharacter array and map dot put. How to put the character. And okay, so it might be the case that this is the first time this character is being put into the map. So what we have to do is we have to, or it might be anytime. So we may have to update the value. So already if the character is there, right? Sorry, map dot, instead of get, we do get or default. So what it does is if already there is an entry with character C, it will get the value, the frequency value. If it's not there, what it's going to do is it will return the default value, that is 0. So this is a method where you don't need to check whether already there's an entry or not. Or you can do, what you can do is you can check if there is already an entry with character C. In that case, you just create a new entry. Otherwise, you just get the current value and add 1 to it. But the things get more easy if you use this built-in function get or default. So if there is no entry, it will return 0 and a new entry is going to be created. So we're done with the first string. Then again, let's do for the next string, t.toCharacter array. What you can do is map dot put we can just check here. We don't need to if map, if the map doesn't contain this key, that means the first string didn't have this character. In that case, immediately I can return false, right? Otherwise, what I can do is I can just check like map.put get, so map.get C. So otherwise it means if I'm not returning here, that means the character C is already in the map. So I get the value for that and decrease it by 1. Okay, lastly, what I can do is I can just go through a for loop in the map and see if all the frequencies have returned to 0. So we can iterate through the map using the key set. So it will return all the characters because the keys are the characters. And I can see if C not equals to 0, then return false. And finally, we can return. If none of these are true, then we can say, okay, return true. So everything was fine. Everything was 0, right? Okay, so let's try to run it. Okay, pass the test cases, and let's try to submit it. Okay, this is accepted. Okay, and this is an order of n algorithm. And then, as I said, we used one map. And the map, whatever the length of the strings are, the map will take at most 26 characters. So the space complexity is going to be constant. Okay, so yeah. The other way to do it is, since you know that this is going to be just this more lowercase English characters, so we can actually use arrays instead. So let's try to do that. So the thing is, we create an array of 26. We create an array of 26. So this is an array, right? Or 0, index 0 to index 25. Okay, and then whenever I get a character, so for each character in this string, say B, right? If I get string B, what I can do is I can just this one we can just subtract the ASCII value of A, and that will give me the index. So I can just go to that index and add one value to it here. So basically I will keep the frequencies in an array of size 26, and then I can just do the same thing like what I did here. So instead of a map, because if I am putting a hash map, by default it may take some extra space, but if I am using an array, I'm just fixed at 26. So I can make it even more space efficient. So let's say integer, instead of hash map, let's change it to map. So it's perfectly fine if you do a hash map or something, but I'm just showing an alternate way. If you have an opportunity that you know the size, the maximum size of your hash map, then obviously you can use and replace it with an array. So I am creating a array, say integer map equals to new int 26, right? Okay. Next, what I do is I read one character, and what I do is I want to see which index I have to update. Okay, so okay, sorry. So this is the ASCII characters, right? So if I get G, ASCII value is 1 or 3. So from G, if I subtract like 97, is going to be 6. So I know that in that map array, I have to update the position 6. Okay, and then next time when I do it here, what I do is map. Initially, what I have to do is I have to fill everything with 0. I have to look for array.fill. What is the way to do it in Java? Arrays.fill. Okay. See, I had missed this. So arrays.fill. Yes, so it will fill this map array with zeros. Next, I am reading the second one. And every time I am getting a character, I'm going to just that character index and reducing it. Next, what I can do is for int, I will now go through the map array, right? Int I equals to 0, I less than 26, I plus plus, because I know that there are 26 entries in that array. And if map at that position, the value is not 0, then I return false, not equals to 0. Otherwise, I return true, right? Okay, so I just replace this hash map with an array because I know that the array size is going to be maximum of 26. Okay, so the test case is passed. And then now it's even more faster, although the time complexity is still going to be order of n, right? Because I have to read n characters and update it here. I have to read again n characters from the second string and update the array here. But the space complexity remains order of 1 because this array has constant size order like 26. So that's it. Thank you very much for watching. We'll come back with another problem next time.